Karnataka Sarkara, Department of Collegiate and Technical Education. Dear students, welcome to the practical section, experiment number 20, Unit 5. Unit 5 is Introduction to Electronic Devices and Digital Electronics. So the course outcome for this unit is identify and test the different electronic devices. So this is the fundamentals of electrical and electronics engineering common to all diploma students. Students, this is a practical session for the bridge rectifier. The bridge rectifier using 4 semiconductor diodes and the bridge rectifier using the semiconductor IC. So the bridge rectifier, it converts the AC to DC. Students, in this practical session, the contents we discuss, that is the practical part. In practical part, title and aim of the experiment is discussed. Then the apparatus required for this experiment is there, and then the circuit diagram for this experiment, that is the bridge rectifier experiment, and then the procedure for this experiment, and then the waveforms of this experiment. Finally, the result. The waveforms means the waveforms which are obtained by using the bridge rectifier with semiconductor diodes and a bridge rectifier with rectifier IC. Both the waveforms are obtained and both the waveforms are compared. So in this session, at the final step, when we compare both the waveforms, we find that both the waveforms are same. The waveforms obtained using 4 diodes as well as the waveforms obtained using rectifier IC. Students, in this practical part of this experiment number 20, the title of this experiment is Construct and Test Bridge Rectifiers using Semiconductor Diode and Construct and Test Bridge Rectifiers using Rectifier IC. Compare the waveforms using CRO. The aim of this experiment is first to construct and test the bridge rectifiers using semiconductor diode. Further, construct and test the bridge rectifier using rectifier IC. Then compare the waveforms obtained by using the semiconductor diodes for the bridge rectifier and by using the rectifier IC for the bridge rectifier. Students, the apparatus required for this experiment is, we need here 4 diodes. We are used IN4007. There are so many diodes are there. So in this experiment we used IN4007, and then transformer is used. So here step down transformer with output voltage 12 volts is used. One transformer we need to conduct this experiment. An AC supply of 230 volt 50 Hz is needed. Then CRO is needed where the waveforms are measured, and then a load resistor of 1 kilo ohm is needed, which is connected across the output of the circuit and where the output waveforms are measured. Then a breadboard and connecting wires are needed. Then for the bridge rectifier with rectifier IC, so in this we need a rectifier IC, and in this experiment we have used the rectifier IC, that is KBPC 3510. So one IC we need to conduct this experiment. Students, the circuit diagram for this experiment, here we can see that the 4 diodes are connected in bridge shape, and to these diodes the input is connected whereas the output is obtained across the load resistance. So in this circuit we see that an AC input is applied at the input circuit and a DC output is obtained across the output resistor, that is the load resistor. So this is the circuit used for the bridge rectifier using diodes, and the same circuit is used for the bridge rectifier using rectifier IC. in rectifier IC where 4 pins are there. So the 2 pins are used to connect the input AC and the 2 pins are used to obtain the output DC. Students, here you can see the breadboard connections there. So here we find a transformer is there. This transformer, to this transformer at the primary side AC input is applied, whereas the at the secondary of the transformer it is connected to the input circuit. The input circuit is the bridge circuit where 4 diodes are connected, and on the breadboard there you can find a resistor is connected at the output side where the CRO is connected and where we obtain the DC output. So in this figure you can see an AC input is applied across the input circuit, whereas the DC output is obtained across the output circuit. Students, the procedure for this experiment is, the first step is that connect the circuit as shown in the circuit diagram, and then the second step is that connect the primary side of the transformer to the AC mains and secondary to the input of the circuit. So the circuit diagram is connected as shown in the circuit, and then when the diodes are used, then 4 diodes are connected in the bridge shape, and when the rectifier IC is used, then the rectifier IC it is connected such that the secondary of the transformer is connected to the AC positive and AC negative pins of the rectifier IC, and then connect the CRO across the resistor. After the connections, switch on the power supply and observe the waveforms on CRO. So the CRO is connected across the output load resistor. So this output load resistor, it is same for the 4 diodes connected in bridge shape as well as the rectifier IC. Students, here you can see the waveforms. V in is the input AC, which is a sinusoidal waveform, and then we obtain the output DC. Output DC, it is the current through the load resistance RL as well as output voltage across the load resistance RL. So the output DC that will contain the current as well as the voltage. Output direct current and then output DC voltage. So here you can see the continuous positive peaks are there. So that is the input AC is converted to the output output DC. Students, the result of this experiment, the output waveforms of the bridge rectifier using diodes are measured across the output resistor, and further the output waveforms of bridge rectifier using rectifier IC are measured across the output load resistor, and we conclude that the waveforms obtained by using diodes as well as the waveforms obtained by using the rectifier IC both are same. So both the waveforms are compared and it is concluded that we get the same types of the waveforms at the output side. Welcome students for the practical session of experiment number 20. The practical part for experiment number 20. Title of this experiment is Construct and Test Bridge Rectifier using Semiconductor Diode and Rectifier IC. Finally, compare the waveforms using CRO. Aim of this experiment is to construct and test bridge rectifier using semiconductor diode and rectifier IC. So, at the end or at the final step of the experiment, we obtain the waveforms on the CRO and these waveforms are to be compared. The apparatus required for this experiment is we need 4 diodes, a transformer that is the step down transformer 12 volt, AC supply is needed, CRO, a resistor of 1 kilo ohm, breadboard and connecting wires, and further a rectifier IC is needed. The circuit diagram is as shown in figure. say here you can see 4 diodes are there, D1, D2, D3 and D4, and these are connected to the AC input, and the DC output is obtained across the load resistance. Here you can see the breadboard connections. On the breadboard you can see 4 diodes are connected in bridge shape, a resistor is connected, and then the diodes are connected to the secondary of the transformer. So the procedure for this experiment is that the first step is to connect the circuit diagram, connect the circuit as shown in the circuit diagram, then connect the primary side of the transformer to the AC mains and secondary side of the transformer to the input circuit, connect the CRO across the output resistor, then switch on the power supply and observe the waveforms on CRO. So students, these are the waveforms we'll observe on the CRO. So these are the output waveforms we observe on the CRO. So here you can see the input sine wave is there, and then the output current and output voltage, it is as shown. Hello students, the components required for bridge rectifier using diodes are like this. Here you can see this is the digital multimeter, and here we need 4 diodes, 1, 2, 3, 4 diodes, and one resistor is there, 1K resistor here we are using. Then a breadboard is there. Using this breadboard all the connections are made, and then a transformer, step down transformer we are using. In this step down transformer, the AC input is applied across this primary coil, and the secondary coil, it is connected to the circuit. So the connection from secondary coil will go to the breadboard. So this is a transformer. Here the transformer we used the step down transformer. The output voltage across the secondary of this transformer is 12 volts. So, and then we need a CRO. So this is the CRO which is used to observe the output waveforms. The output waveforms which are obtained using diode as well as which are obtained using the rectifier IC. Students, now let's see the circuit diagram. We'll see the circuit diagram here. This is a breadboard on which the circuit diagram is connected. Here you can see 4 diodes are connected and the output resistor is there. The AC input is applied. AC input from the secondary of the transformer. This is the secondary of the transformer. This secondary of the transformer, it is connected between these 2 points. This is, say, here you can see the black wire and here you can see the red wire. So let us check the circuit diagram there. If we see the circuit diagram, here we are having the circuit diagram. In this circuit diagram we see 4 diodes are there. Here also the 4 diodes are connected like this. So these are the 4 diodes. So the input is applied. This is the AC input. AC input, it is applied at this point where, say, the anode and cathode of the 2 diodes are there, and similarly one more point is there where the cathode and anode is there. So between these 2 points AC input is applied. The AC input, it is applied from the secondary of the transformer. This is the secondary of the transformer. You can see here the connection here. So this is the point where the AC input is applied. Here one wire from the secondary and one more wire from the secondary here at the both the points. That means these 2 points at the both the points. These 2 points AC is applied, and then here you can see the resistor, it is connected at the output side. The resistor here, this is the load resistance, it is connected across the output side. Here you can see here the resistor load, it is connected at this point, and one more point it will goes to the ground. So here we can see this is the resistance connection. and here it is connected. Actually this is the ground there, so that here the one more end from the diodes, that is from this end, it is also connected to the resistance. So this end where the two terminals of the diode are meeting, say from here, it is connected to the resistance. So this is the connections for the bridge rectifier. Here you can see the 4 diodes are connected in the bridge shape. So the AC input is applied from the secondary of the transformer. So here to the primary of the transformer, the AC is applied. So here you can see, and then the secondary of the transformer, it will contains the reduced voltage which is reduced to 12 volts. So actually here we are using step down transformer. Then further the output waveforms are observed across the load resistance. This is the load resistance using the CRO. And further here the voltages can also be measured by using the multimeter also, but here we will use only CRO. Why? Because we want to check the output waveforms. Let us check the output waveforms. So to check the output waveforms, first we have to give the AC input to the transformer. Students, according to the procedure, we are already connected the circuit diagram as shown in the circuit. So this is the circuit which I already connected there. So I have made switch on the circuit there. This is the mains, AC mains, which is applied to the primary of the transformer, and at the secondary of the transformer the 12 volt AC is obtained, and this 12 volt is to be applied to the input circuit. The 12 volt AC, it is like this. So here in the CRO we can see the input AC voltage, which is the sine wave. Students, here according to the waveforms, here you can see this is the input AC sine wave. So the same waveform we have obtained in the CRO. So this AC input is applied across the 2 diodes there. Here it is applied. So now let us see here. After applying this, we will observe the output across the load resistance. The output across the load resistance is the rectified output or the DC output. So the CRO is connected across the 2 ends of the resistor. So on the CRO we can see the rectified DC output. So this is the rectified DC output. Students, in the waveform I will once again show you. So here this is the input waveform and this is the output waveform. So this input waveform we already observed. Now the output waveform is the DC output. So this is observed on the CRO. So on the CRO you can see the rectified output or converted DC. Students, now let's see the output waveform for the bridge rectifier using bridge rectifier IC. So the IC which we are using, it is the full wave rectifier IC. It total contains 4 pins. So among these 4 pins, so 2 pins are used for AC input and the DC output, it is obtained across the other 2 pins. So the circuit connection is same for this also. Here we will take one IC and then we connect across the input AC and then DC output is obtained. So the pin diagram is like this. These 2 pins are used to connect the AC input and these 2 pins are used to observe the DC output. So here the procedure is also same there. After connection there, say connect the primary side of the transformer to AC mains and secondary to the AC positive and AC negative input of the rectifier. Then connect the CRO across the resistor, switch on the power supply and observe the waveform. So these are the waveforms which we are going to observe. So for this experiment we need a rectifier IC
This is a rectifier IC. So many rectifier ICs are there. Here I am using KBPC 3510. This is a rectifier IC. So students, you can see total 4 pins are there. Among these 4 pins, here you can see AC plus and AC minus pins are there. So to which these 2 pins we are going to connect the AC input, and then the DC output, it is obtained across these 2 pins. So the secondary of the transformer is connected to these 2 pins, and the output DC is observed from the CRO across these 2 pins. And here we need connecting wires, a breadboard is there, and we need a resistor also, a 1K resistor we are using. So across which the output is going to be observed. So as usual, we need the step down transformer, and then we need a CRO. Students, the connections are made as shown there. So the secondary of the transformer, it is connected to the 2 AC inputs, A plus and A minus, and then a resistor is connected across the DC output. Here this is connected, the resistor is there, this resistor, it is connected across the DC output. These are the connections. After connecting the circuit diagram, then we will switch on the power supply, and then we observe the waveforms on the CRO. So the input waveforms, those are AC waveforms, and then the output waveforms, those are the DC waveforms. DC waveforms are observed across the output resistor, load resistor. Students, these are AC input waveforms applied to the input. Students, these are the DC output waveforms which are obtained across the 2 output pins of the rectifier IC. You can observe same waveforms are obtained. Now we will conclude that the output of the bridge rectifier using diodes as well as the output of bridge rectifier using rectifier IC will be having the same types of output waveforms. So when the AC input is applied, the output DC is same for both the diode rectifier as well as rectifier IC.
Students, thank you for watching this video. I thank you on behalf of all the LMSE content team members. I hope we are successful in our efforts to make you to understand this session clearly. Now this is a teamwork, so to make you to clear the concepts so that you can understand the subject more clearly. Thank you, students.